Example 4, I see more than one variable term, and so I immediately know I can't isolate. It means it's going to be a little bit hard. I want to, in that case, I want to try to factor. If I can't factor, I'll have to do something else. So let's see. Okay. If I was going to try and factor, I'd need a 0 over here on the right side. So let's kind of get rid of this parentheses, distribute that. You've got cotangent squared x plus 3 cotangent x and equals 1. I'm going to subtract that over, slip that over there. Minus 1 equals 0. Kind of did something in my head. I hope you can handle that. Cotangent squared x plus 3 cotangent x minus 1 equals 0. Maybe that looks better to you, maybe not. But what it reminds me of is this, x squared plus 3x minus 1. That looks like a factorable problem. Looks like I want to factor it. Okay, that's good. But if you think about it, I'm trying to come up with two numbers that multiply to -1 and add up to +3. I can't figure that out. I can't factor that. And so if you can't factor this, then maybe we can do quadratic formula. Okay, quadratic formula, if you don't have this written down, maybe you should write this down. Negative b plus or minus square root of b squared minus 4ac all over 2a. Wouldn't hurt to memorize that, but it is on the wall, and you can see it there. But I'm going to try and solve this thing using that quadratic formula. Okay? So we can see negative b, -3, plus or minus the square root of b squared, 3 squared would be 9, minus 4 times a. Remember, a is the number in the front. That's going to be 1 here. And c is the number that's in the back there with no variable connected. That's -1. And all that's over 2 times a. So there's a setup of the quadratic formula. You would notice you've got a -4 times a 1 times a -1. That's +4. That's +4 right there. So you're going to have 9 plus 4 is 13. I see -3 plus or minus the square root of 13 all over 2. Okay. And so I want a calculator for my square root of 13. Square root 13, 3.6056. So I'm gonna call this 3.6056 right there. So I've got -3 plus or minus 3.6056 all over 2. And so when you see that plus or minus, keep in mind that means two different problems. We're going to go through and do that if it said plus, and then we're going to come back and do it again if it said minus. So -3 plus 3.6056, and then divide all that by 2. We would get 0.3028. Okay. Or if we come back and do the subtraction, what it would look like with a minus, we would say -3 minus 3.6056. All that divided by 2. We get -3.3028. Now, another thing that's tricky about the algebra here is when we were in algebra class, we were finished. This was the end, and we circled it, and we moved on. But what you have to understand is this equation right here isn't really here. We're not solving for x. Quadratic formula, we're normally finding x, but that's not really the variable that we solved for in this problem. Okay? Cotangent x is acting like the variable, and so really when we did quadratic formula, we're not finding x there. We were finding cotangent x. And so we've got, really what we've got now is two different equations. Cotangent x equals each of those two numbers. We still have one more step. We still have to do the trig step. And I want to isolate this variable. I can isolate this variable by doing an inverse cotangent. I can take an inverse cotangent of both sides. And that would be awesome if my calculator had an inverse cotangent button on it. My calculator does not have an inverse cotangent button on it, so what I'm going to do is flip it around. Let's do the reciprocal. Let's do the reciprocal on both sides and turn it into a tangent, because my calculator does have an inverse tangent button. If I wanted to solve this, I could take an inverse tangent on both sides. So x is going to equal the inverse tangent of that reciprocal, 1 over 0.3028. So we would type that in. Now, for some reason, this problem doesn't tell you whether to use degrees or radians. Usually what that means when it doesn't say it's going to be in radians, but I want to make this problem a little bit easier for you to understand. So let's just assume that this is in degrees. I think you'll understand it a little bit better if we're in degrees, so that's what. So let's make sure my calculator is in degree mode. And we're going to do an inverse tangent of 1 over 0.3028. We'll call that 73.2. Okay, 73.2 reference angle. There's your what, but keep in mind that we have to think about where. It's 73.2 where tangent is positive. So we know tangent is positive in the first and third quadrants. And so the first one just is what it is, 73.2 degrees. But that second one is going to be 73.2 past 180. So 253.2. That second answer is 253.2 degrees. Okay. So then we look at the other one, and the other one we got to do kind of the same thing. We can't do an inverse cotangent, so we have to do a reciprocal here. Change it into tangent. We tangent x equals 1 over negative 3.3028. We can do an inverse tangent. X is going to equal inverse tangent of that reciprocal. I get a negative 16.8, okay? I think it's probably better for you to think about this as a 16.8 where tangent is negative. Okay? We're going to think about 16.8 where tangent is negative. And so, tangent is negative in the second and the fourth. 16.8 in the second and the fourth. So, this one is going to be 180 minus 16.8. $163.2. And then the other one is going to be 360 minus 16.8. $343.2. Now, not quite finished, because I didn't quite answer the whole question. All right? What I've just found would be the answers between, not 0 and 2 pi, but 0 and 360. I found all the answers in between 0 and 360. I don't know if anybody noticed, but this doesn't say that. It says find all the solutions. And so that adds another layer onto this problem, makes it a little bit trickier. If I'm going to find all the solutions, but just think about it. Here's a 30-degree angle. If I add 360, I'm back there at the same place. 390 is 30. The same place as 30. Add 360, add 360, add 360. You just keep adding 360, you're going to get back to the same place. And so that's what I'm going to do. Instead of 73.2, I'm going to say 73.2 plus 360 in. That'll get all of them. And 253.2 plus 360 in. And 163.2 plus 360 in. And 343.2 plus 360 in. That would give me all solutions. And not just the ones in between 0 and 360.